Now, let us go to the next question. Go and read the fourth question.
If triangle and square each represent single digits in the decimal above, what digit does the triangle represent?
Perfect. So again, this is a clear-cut, regular data sufficiency question type, right? So for regular data sufficiency question type, we are going to ask ourselves three simple questions, right? First one is, what do I need to find out? So tell me, what do we need to find out?
The value of the triangle.
Exactly. Triangle is equals to what, right? Triangle is equal to question mark. Wonderful. Then the second question is, what do I know, right? So tell me, what do I know?
The value, that is 3.2 triangle square 6.
Exactly. Here we know the value, that is 3.2 triangle square 6, right? Wonderful. Now the third question is, what else do I need to know? What else do I need to know? I need to know some more information on triangle and square, right? Wonderful. Now let us go to a fact statement and see whether the fact statement will help us to find the value of the triangle, right? So first we write PD upon BCE. Okay, then we go to the first fact statement. Go and read the first fact statement.
When the decimal is rounded to the nearest 10, 3.2 is the result.
Perfect. When decimal is rounded up to the nearest 10, 3.2 is the result. That's the first statement, right? So tell me, when can this be possible? What can be the values of triangle so that when the decimal is rounded up to the nearest 10, we get 3.2?
0, 1, 2, 3, 4.
Exactly. The values for triangle can be 0, 1, 2, 3, 4, right? So for any value, when we round it up this to the nearest 10, we get 3.2, right? So we got so many values for triangle, right? We don't have one definite value for triangle. So tell me whether this is sufficient.
No.
Obviously not sufficient, right? Statement 1 alone is not sufficient. Therefore, we knock off answer choices A, B. Great. Now let us go to our second fact statement. What is the second fact statement?
When the decimal is rounded to the nearest 100, 3.24 is the result.
Great. So from the second fact statement, we got when the decimal 3.2 triangle square 6 is rounded up to the nearest 100, the result is 3.24. Now, when is this possible? This is possible in two scenarios. Okay, let's take a look at that. The first one is 3.2 and triangle value is 3, right? And then the square value can be 5, 6, 7, 8, and 9. Okay, right? So in the square value is 5, 6, 7, 8, and 9, triangle can be 3, right? So when we round it off, we get 3.24, right? Or we can also have 3.2 and here triangle value is 4, whereas the square value would be 0, 1, 2, 3, 4, right? So when the value of square is between 0 and 4, triangle can be 4, right? So that when we round off the nearest 100, we get 3.24, right? So here, depending on the value of square, we got two values for triangle, right? That are 3 and 4, right? So tell me, is this sufficient?
Not sufficient.
Obviously not sufficient, right? Because we need one different value for triangle, and here we got two values. Therefore, obviously this is not sufficient. Hence, we now have answer is B also, right? Now let us combine both. Let us combine both the fact statements and see whether we can get a definite value for triangle. Okay, so if we combine both the fact statement, let us see what we get. From first statement, we got value of triangle can be 0, 1, 2, 3, and 4, and from second statement we have value of triangle can be 3, 4, right? So if we combine both, still we got the value of triangle as 3, 4, right? We still don't have one definite value for triangle. Is it not? So tell me whether this is sufficient.
No, it is not.
No, right? Obviously not sufficient. Even together it is not sufficient. Therefore, we knock off answer as C. Hence, the correct answer here is answer is E. Right? Is that clear?